Welcome to our live webinar on how to deploy flexible cloud-based automation solutions quickly and easily. Today's webinar is sponsored by Iconix, Soap Engineering, and Automation.com. My name is Renee Bassett, Chief Editor of Automation.com, and I will be your host. The latest software technologies are being used to improve automation system performance and leverage digital twins for robust remote monitoring and better preventive maintenance. Implementing these solutions, however, often brings connectivity challenges that can lead to long implementation times. In this webcast, you will learn about the Iconix suite of software and system integrator Soap Engineering, who has developed a hosted service on the Iconix suite that addresses some of the challenges. Soap Engineering's digital twin solution leverages Microsoft Azure IoT services to achieve remote monitoring for critical assets. Use of the Iconix suite allows for rapid deployment to Soap's oil and gas customers. The result is substantial business value and improved compliance around regulatory safety. Before we get started, please take a moment to acquaint yourself with the features of this GoToWebinar technology, so you may submit questions to our presenters at the end. You also may submit questions anytime. On the right of your screen, you'll see the Questions tab. Simply click on the text box, type your questions, and send it. All questions will only be seen by me and our speakers. Once the main presentation is over, I'll be asking our speakers to respond to as many as possible while keeping the overall presentation time to 1 hour. Also on the right, you will see a tab for handouts. Navigate there to download some additional material from our speakers. This presentation, including the Q&A session at the end, is being recorded. You will receive a link via email for viewing it later on demand. Now some background on our speakers. Mark Hepburn is Senior Vice President of Worldwide Sales for Iconix. He joined Iconix in 2003 to lead the sales team in helping customers leverage invisible digital operational data to improve productivity and integrate with enterprise systems. Hepburn's 35-year career includes 15 years with General Electric in sales and marketing positions for design, engineering, e-commerce, and digital media. Morgan Nelson is Soap Engineering's SCADA Solutions Manager, focusing on system integration products utilizing a variety of SCADA platforms. Morgan is responsible for integrating new technology trends into Soap's customized solutions. Prior to joining Soap, Morgan was the program director for our corporate engineering group at NOV, where she was responsible for the integration of OSIsoft PI Historian into the existing product line. Now, without further delay, I'll hand over the mic and presentation controls to Mark from Iconix. Welcome, Mark.
Thank you very much, Renee. Really appreciate the opportunity to join this illustrious team. So without further ado, just like to thank Morgan Nelson from Soap for joining me. Morgan's down in Houston, Texas, where they've had lots of trouble the last couple of days with cold weather. So thanks, Morgan and the Soap team for joining. I'm going to give just a brief overview of the Iconix automation software suite and how the digital twins elements fit into a system like Soap Engineering is created on the cloud with SCADA. So just very briefly about Iconix. We were founded in 1986. We're a software vendor. All we do is create software tools for systems integrators like Soap Engineering and hundreds of others of partners around the world to deploy systems across a wide variety of industries and applications. There's over 375,000 installations worldwide, and we're very pleased to be recognized by Microsoft multiple times as the winner of the Partner of the Year Award. In fact, 9 times recognized as a Partner of the Year, 6 times winner. We are a member of Mitsubishi Electric, group company of Mitsubishi Electric. And, with Iconix and Mitsubishi Electric together, we serve a a wide range of applications across many industries. Today, we're going to focus on oil and gas, but the exact same software and methodologies apply to distributed data coming together in a digital model. We'll call it digital twins, whether it be in automotive or buildings or water treatment or transportation. The elements of gathering disparate data, making sense of them, putting them in context, displaying them, and driving action and decisions fits really across all industries. The Iconix suite of tools is based on 4 primary categories we call Genesis 64, which is our flagship HMI and SCADA product with advanced visualization, distributed alarm management, and data logging, the core components of HMI and SCADA. The Hyperhistorian, which is an advanced historian set of components, the analytics modules, and our IoT suite, all of which are developed by Iconix and exist on one platform, one framework, the Iconix suite framework. So they're all interoperable, designed together, and work together for production management, for oil and gas system management. There's a bunch of tools, of course, built in with the data historian. We have some analytics around energy management, around fault detection diagnostics, for discrete automation around SPC and quality, in discrete automation around the elements of OEE and other KPIs, scheduling, reporting, and then the ability to visualize really on any client. And our brand names are Web HMI, Mobile HMI, and KPI Works. The Iconix visualization is on any glass. So this means it can run on your desktop, it can run on tablets, it can run on your watch, it can run on augmented reality devices such as the HoloLens or RealWear, for instance, and of course, mobile on your phones and tablets. And all of this, the Iconix suite runs on premises, 375,000 applications, hybrid or cloud. And so you can run the Iconix system. Generally, when we talk cloud, that means hybrid. That's a significant on-premises element. And we're going to talk in Morgan's example of how the cloud is used for a digital twin of the on-premises system. So we use the software to develop applications across many different types of use cases, whether it be smart spaces, where we're trying to reduce energy costs, or field service, where we're looking at accelerating dispatch and working with the operators in the field to identify, fix, and repair and respond to equipment failures or anomalies. Around advanced visualization, whether that be in the plant or hands-free operation with mixed reality, remote monitoring. So, most of the applications we have involve some kind of remote monitoring where we're taking data from remote systems and monitoring and or controlling around predictive maintenance and around the connected machines that are in the operation. And so when we think about this concept of digital twins in the context of whatever operation, we need to collect data from whatever those data sources are. And Iconix has a very flexible integration platform that works together with other cloud services, notably around the Microsoft Azure platform and Azure services, leveraging tools like the Azure IoT Hub, but also other data center environments, including other clouds like Amazon Web Services, where we're taking data and securely transporting it one way or another into the Iconix suite. We'll discuss the Iconix edge technologies, but there are many ways of getting data, whether it's from mechatronics, the control systems that are sitting at the edge, or from informatics, either at the edge or other cloud-based information systems together in one system. So why do people use digital twins? It's for the things we've talked about, right? Continuous monitoring, alarming, historical analysis to compare actual against set point or actual against actual. It's to increase efficiency, lower cost of ownership, to improve performance, reduce downtime, generally for faster responsiveness. And digital twins gives us the ability to create context between the things in the physical world and the digital world, right? So we're able to create a digital model of the physical world in the digital space, in the Iconix system, and together with other systems that describe geometry, right? The product lifecycle management or CAD systems, and then the digital twin of the telemetry, the actual data, the real-time data around those gets captured in the digital world for things like remote monitoring or fault detection or diagnostics and predictive maintenance. And if we relate the telemetry, the data coming from those things, to the places where those things operate, we can gather even more context and create more value for the operator and the users of the system. So we may take where a specific element is being used. Obviously, there's a geometric element, there's a mapping element often, and then we look at other things. So we might look at analytics around flow or occupancy or space utilization or asset tracking, and we combine that with the elements of the people, right? So who is using it, how are they using it, and we get even richer context. So when we combine these elements with geometries that we describe in the product lifecycle management and analytics, then we have a human-machine interface, an operations control panel that allows us to act on that data in real time. And we do this by collecting the telemetry data and other management information system data coming from web services or databases and creating context, right? So I can have a specific piece of equipment and I'll pick up elements like the speed, pressure, humidity, or temperature related to that asset, but also bring in the people and places, as we talked about, and other asset metadata. When was this acquired? What manufacturer? Where's the video for training, for operations? All of the asset metadata, and then we combine that together into a logical structure for the asset. We call that element AssetWorks, this tool of creating an asset structure. Microsoft calls it Azure Digital Twins. And we see a whole large movement towards normalizing the asset structures. And so we'll see in Morgan's presentation how they've leveraged this organization methodology. So we can take things like the geometries, the graphics around an object, and combine that with the digital twin of the data elements coming from the telemetry, and then we do simple things like create KPIs that measure rates of change and thresholds and targets, etc. As I mentioned, the Iconix tool for digital twins is we call AssetWorks. So AssetWorks is Iconix digital twin tool. It helps us to organize data, all that telemetry data from the Genesis 64 system. So this connects to any data coming from the outside world and also internal data from the alarm system, HyperHistorian, our own analytics. It is a multi-level distributed type of system. AssetWorks as is one of the core elements of Genesis 64. We can take multiple versions of Genesis 64, multiple AssetWorks catalogs, combine them. These can be dozens. They can be distributed in however logically it makes sense, and they can run on premises and or in the cloud. And of course, we integrate the alarms and the historical data. Using this methodology, we can scale to millions and billions of data points together in one data catalog. We introduced the concept of reusable equipment classes to describe specific pieces of equipment. It follows, of course, a very logical asset structure like we see described in ISA 95. We have the ability to do totalizations and notifications and alarms within the visual element within AssetWorks. So we call this Asset Navigator, and to have actions that are performed on the screen. And of course, we integrate other analytics. So I mentioned the ability to create actions from the visual element. We call this our Asset Navigator. Within the Asset Navigator, we can add icons, we can add alarm status, we can change colors, and these things can be animated, and then we can click scriptless actions, so commanding here, and so you see a large number of commands. Right, so I mentioned the historical data. Iconix has an enterprise historian we call HyperHistorian. It also has a distributed architecture, and you'll see in the project that Morgan is going to talk about a use of a distributed data collector, and that has the ability to connect to a wide variety of data, particularly leveraging OPC UA, but BACnet, SNMP, web services, MQTT, all of these, including offline data. So we bring data in, we log the data, have a distributor logger methodology, including redundancy, and then of course we have to visualize that data. We would normally do that in GraphWorks 64, part of Genesis 64, but also that data is exposed to other services, including Azure Data Lakes and Power BI and any other analytics application, Hadoop, etc. And then we have advanced performance calculations with a library of built-in statistical functions that make it an advanced historian, and with pre-configured tools like Energy and SPC and OEE. How do you get the data securely from the edge? There's a number of ways to do that. Iconix has an edge platform we call IoTWorks. It includes the ability to collect, historize, analyze, and visualize data, and then securely transmit that to the Iconix suite or to other applications leveraging AMQP, MQTT, REST, and HTTPS. We use a trusted platform management and X509 TLS security from IoTWorks. But the basic idea, you have to get that data into the digital twin, and then you can do your visualization and operations control and management. With that, I'd like to switch to Morgan to talk about a real example how all of these tools can be used to accelerate a system for real operations. And I think, Morgan, you're going to show an example of how SOAP Engineering has done this. So with that, I'm going to pass the screen to Morgan.
Right. Thank you very much, Mark. So today I'm going to go over a specific case study, but to get started, let me just give you a little bit of an introduction to my company. So I work with SOAP Engineering. So we are turnkey system integrators. We do everything from instrumentation, PLC controls, to HMI and SCADA automation. Over the past 5 years, we've worked on multiple projects working with IoT implementations and also a lot of cloud hosting of the servers. We are based in Houston, Texas, and we do have offices worldwide. So we have had quite the week here with the ice storm, the ice apocalypse, as we're calling it. Soap engineering serves multiple industries, from building automation, food and beverage, manufacturing. The case study that I'm going to show you today is an example from oil and gas. So before I get to my case study, I just wanted to go through some industry trends that I see as a system integrator that customers are kind of, coming to us with. The first thing is that a lot of customers have existing hardware and software out in the field that they don't necessarily want to spend money to replace as long as it's working. So a lot of our customers are just looking to add a layer of monitoring to their existing solutions, utilizing what they already have and modernizing with a remote monitoring platform. So this could be a situation where they want to provide access to management back in offices, or if they have a control room that they want to do an upgrade of. I see a lot of customers that just focus on trying to add that layer of modernization without having to touch their existing control systems. The next thing is minimizing the time it takes to execute a project. A lot of people with their budgets in today's climate are looking at ways to have small projects as a part of a larger scale multi-year project. To be able to do this effectively, they're looking at a way to create repeatable implementations. So how can I take my data and create a template or some sort of blueprint that I can then use throughout all of my assets? So that is something that we have found Iconix to be a very helpful software platform for us because of the templates and the ease of use with deploying the architecture to allow us to execute on these types of projects where a customer is looking to create one type of design that can be deployed across all of their different assets or all of their different fields. Another thing is remote cloud hosting. So people are looking at ways to reduce their maintenance cost. I think a lot of companies are also outsourcing their IT, so they may not have the staff they had before to manage all of the servers required to run their automation systems. So we see a lot of people are looking to do remote or cloud hosting, utilizing different platforms like Azure or AWS to reduce that cost. With Iconix, it's very easy to set up that platform in a cloud environment. So really, it's ease of use for the end users that are managing the Iconix platform in that cloud hosting. And the last thing is SCADA as a service, and this relates directly to the case study I will go through today. Again, with reducing of cost and also not just cost of hardware and software, but also cost of staff to maintain the system, we're seeing that people are also looking more towards SCADA as a service. I think that in today's world, there's so many service offerings that you see. There's Uber Eats and Grubhub for you to have a service for someone to bring you your food. You can get your groceries delivered. Your pharmacies have deliveries now. So I think that this service model even relates to different industries as well. And so we're seeing that SCADA as a service is becoming a lot more popular. So today's case study is going to focus on offshore blowout preventer monitoring. So I'm sure you are familiar with the Deepwater Horizon disaster that occurred in 2010. This was a failure of the blowout preventer. So in the video I'm showing here, it's just showing you this blowout preventer. It's the piece of equipment that sits on the ocean floor that regulates the pressure of the fluid coming from the ocean floor up into the rig or vessel. So here it has a system to regulate that pressure, and it also has a cutoff so that it can stop the flow and prevent that fluid from going up to the rig or the vessel. So during this disaster, that is the piece of equipment that failed. So since then, there have been a lot of different government regulations that have been put in place. And for this case study, it's really about real-time monitoring requirements for all of the high pressure activity, which means the data being read for this blowout preventer has to be sent back on shore as long as they are actively drilling. So this regulation is important that they're in compliance. And it's also important for safety because it is a big safety risk if this piece of equipment is not working properly. So when SOAP learned about this situation, they found that there are manufacturers that have different versions of this physical piece of hardware for the blowout preventer. And as they've delivered these different versions throughout the past 10 years, they have also delivered these monitoring softwares that meet the compliance requirements to bring that data back on shore. Unfortunately, a lot of those solutions for their older versions of this equipment have obsolete hardware and software that they're running on. So what SOAP has done is created a turnkey solution that will replace the monitoring system for these BOPs. So it's for monitoring as well as for maintenance calculations to let them know when certain components need to be replaced. So the solution we've created is called Orion. It stands for Operational Reliability and Integrity for Offshore and Nearshore. So for our customers, when we were looking at this solution that we were developing, the biggest challenges they're seeing are these hardware and software obsolescence. So the operating system on the servers, Windows, old Windows operating systems that are no longer supported at end of life. Same is true of the legacy HMI, and also the database they were using was Microsoft Access. Along with this, the servers that were provided to run this solution were only a single server. So all of this led to a single point of failure with the existing solution. If the existing BOP monitoring and maintenance solution were to fail, they would lose that HMI display that they had in their control rooms. They still would have the physical panels where they do the operations, but it would just kind of give them a lack of visibility. They also would no longer have the ability to log that data, and which would mean they would no longer be able to transfer that data onshore. All of this would mean that they could run the risk of getting large fines from not being in compliance with the government regulations and potential downtime. So for these offshore operations, downtime is very costly, so it's something that they're hyper vigilant about. This system also looks at maintenance, so if it's down, it also means that their visibility into maintenance of this equipment would also be lost. So when SOAP was assessing this, we were looking at how we could best provide the solution. We settled on using the Iconics platform because of its ease of use and its short time to deploy. So with a traditional solution, the existing vendor was offering this solution at 3 times the price that SOAP was offering it. They also were saying that to create the solution, they would have to develop new software that would take up to a year to be able to deploy to these vessels. With using Iconics, we were able to use their features for templating, and we were able to deploy this with 10 weeks. So that 10 weeks of time includes the time to do any development, do the testing onshore, and be able to ship those servers to the vessel. So really quickly, I just wanted to kind of give an idea of the architecture that is deployed for this solution. So on the vessel, there are 2 different networks. There's the BOP network and then the local area network. The BOP network is separate just because of the safety nature of these blowout preventers, that it's separate from the rest of the vessel. So the way the Orion solution works on the vessel is that we now have 2 servers that are redundant. We're using Iconics suite as well as the Hyperhistorian to collect and visualize the data locally, and that data is visualized in the control room. We have a gateway installed on the vessel that's using the local area network to read that data from the historian, from the local on-prem solution, and then that gateway is sending that data to a cloud environment. In the cloud environment, we have the same setup as the on-prem environment, where we have the Iconic suite and redundant historians. And in the gateway itself, we're using a tool of a Hyperhistorian collector from Iconics that allows us to communicate data from one historian to another to make sure that those two historians are always in sync. The remote version that's hosted in the cloud is visible from any glass devices. So we have a web HMI as well as mobile HMI options for users to access. So the benefits of our service solution with Orion, I think the first and easiest one is redundancy. There's multiple levels of redundancy with the solution that we've created. First, on the vessel itself, for the local visualization and maintenance, there's redundancy with those two servers. Adding the remote monitoring piece as well adds another level of redundancy with having that data brought back to that cloud environment for storage and for viewing. We're using the Hypercollector from Iconics. That works is, so on the vessel there is satellite communication connecting the data to the cloud. If for some reason that satellite communication goes down, the local historians are still collecting the data. Once the communication comes back, the Hypercollector will merge all the missing data to the cloud. So there's really no buffering activity that has to happen or storing forward, because as soon as the data connection comes back, the Hypercollector will just fill in the data to the cloud historian. Mark kind of touched on the different data connectors that are available with the Iconics platform. So I just wanted to note that for this project, we are using the Hypercollector, but there are other ways. We've worked on integrations where we send data back to a Pi historian. We've worked with the IoTWorks product using MQTT protocols, and then we've also done a lot of integrations with OPC. The nice thing about Iconics is that it's backward compatible to the existing blowout preventer systems in older generations. So it doesn't matter how old the PLCs are that we're connecting to, we're still able to pull that data into the Iconics platform and visualize it locally and in the cloud. And the biggest thing, and Mark talked a lot about this in his presentation, is the easy features of Iconics that allow you to create templates. So AssetWorks is allowing you to create templates of the data. So for this, it's not only important for our customers, but also important for us as system integrators. This solution is something that doesn't apply to a single customer. It applies to multiple customers that are using this piece of equipment. So with using AssetWorks, we can create templates for how the equipment data is sorted. Then when we go to the next customer, we can utilize that template to deploy this quickly. The same is true with GraphWorks. The way that the symbols and layouts of the screens work, and in conjunction with the AssetWorks feature for managing the data, it allows it to be these template features that allow us to easily deploy. And from a template, we can quickly customize for a customer and then deploy those features. The Iconics suite has very advanced graphical features. For this particular deployment, we were keeping the interface similar to what they currently had, but we were able to take 3 different interfaces and merge them into one integrated look and feel for the user. So that's for the monitoring, the function logging, for the use of the different components, and then also for maintenance and diagnostics and reporting that goes along with that. We were also able to utilize the Iconics mobile app. What's nice about that for deploying is that the app itself is a native app, so it has that look and feel that people are used to when they're on their phones, of using an app and navigating, using your thumbs. What's also nice is when you create your WebHMI screen, it's very easy for you to convert that to a mobile version. Depending on how you created the screen, you can use the exact same screen to be deployed on mobile, or you can easily convert that into, let's say, a portrait style so that the flow and navigation of the screen works better for a mobile device. But it's very easy and doesn't take very much time to deploy to mobile. And then the trending features was a big upgrade for the customer. In the previous solution, they only were able to store 7 days of data. So now that we have the redundant historians in the solution, we have a lot of data and can use the trending within the Iconix platform to allow them to, do a lot of comparison with their data through trending. And then I've already talked about the historian, but that is a very big benefit to the customer because they have that historical redundancy. In the current solution, they're just looking at the real-time function and maintenance, but it also will allow them to start collecting the data and looking in the future to analytic solutions that they might be able to use that data for. So the last thing I wanted to do was kind of just give you a view into what the screens look like. I just have screenshots to show you for the sake of making sure that there weren't any internet issues. But this view is the fleet view. So this would be for the customer if they had multiple vessels that were on this system. So here, this would be a management person looking to see the different issues that might come across and comparing their different vessels. So this is only looking at the blowout preventers. So on the right-hand side, you'll see we have different images indicating that actual piece of equipment, and the different colors, the yellows and the greens, are different statuses of where the equipment is, whether a certain component is open or closed, whether a valve is open or closed. We have the ability to give them some quick view into alarms of how that system is operating. There's also a trend feature, so they can start to look at alarms, not just for the equipment itself, but looking at the different components of the equipment, and then just some maintenance statistics that will tell them how different components in the system are operating. These maintenance numbers are counting the number of times it has cycled or been used, and those are helpful to know whether a component is coming up for maintenance. Then for the vessel view itself, this would be the main dashboard that the user would come into. So with all of the symbols that you see on this screen, these are all templates. So the data behind this is connected to AssetWorks. So we can easily take this same design and deploy it to different customers. On the left-hand side, you see where it says Free2One Dashboard Surface LMRP. This is the asset navigator that Mark had mentioned. This is showing you how the data is actually organized in the back end of the system using the AssetWorks tool. So we can take the way we organize the data into those templates and also use it as a navigation element, which is really helpful for the customers because they've defined these different units to say this system, this piece of equipment is broken into these different components. From here, we can set symbols that are consistent. So if I have an alarm symbol with the triangle with the exclamation point, I can click it and it will open up an alarm viewer. So this is just a table that will show them the alarms and allow them to do sorting. I also can, from this main screen, I can navigate from the screen by clicking one of the black arrows, and this will take me to a screen here. This one is just comparing different values, and this one would allow for trending. So on the blowout preventer, there is redundancy with a component called the pod. So this is just showing the differences between those two redundant units. So the blue version versus the yellow version. And then I also can look at one of the panel screens. So here, this panel screen is showing the status of all of these different components for the equipment on the surface of the unit. The nice thing about this screen is that this is the same screen I would see on the vessel or the same screen I would see remotely as well. if I was accessing the remote system. So this gives the ability for operations staff on the vessel to have support from the people that are back on shore for troubleshooting or performance optimization as well. So that concludes what I had to show here today. I'm going to go ahead and pass the baton back over to Mark for a conclusion.
Thanks very much. Really appreciate, Morgan, that excellent presentation, all the perspective that you've given, how these tools can be applied, of course, to blowout preventers, a really critical function, to any oil and gas, offshore, onshore, or really to any kind of distributed asset-based model that needs a digital twin in the cloud. Okay, so if you could just go to the next slide, please, Morgan. I just wanted to talk just very briefly about how we support our systems integrators and end users. And of course, with Iconics, we have extensive training. We've Iconics Institute with online training available to everybody. Very, very useful learning how to use the products. Of course, we provide technical support under our SupportWorks program to our systems integrators and end users, and we have pre-sales solution help for our systems integrators to help them with architectures and presentations, and to also assist our systems integrators. We have our own specialized professional services group to help with those unique aspects around architecture, consulting, design, specialty training, that sort of thing. And so the SOAP Engineering is a member of the Iconics Systems Integrator program. They're a gold certified systems integrator. Getting started is easy. We have a registered systems integrator, no cost program, and then people enroll to get access to more services. And we recognize our systems integrators as certified and gold certified based on their skills and experience. So with that, I think maybe we should turn over to Renee to facilitate some Q&A. I want to thank everybody for joining.
Thanks, Mark, and thanks, Morgan. Excellent presentation. Now I want to just remind everybody that we are taking questions. We have some that have already come in, but you are still able to provide questions to us by clicking on the questions tab on your screen and hitting send. We'll get to as many as we can within the next 15 minutes or so. But let's start with a question for Morgan. You may have answered this question, Morgan, but somebody was asking what is the operating system that Iconics is running on the rig?
So it's running on Windows on the rig, but Mark can maybe elaborate on this more. In some of their edge solutions, they also run on different platforms. I know they have a Linux platform they can use for IoTWorks, but in this solution, we're running the full Iconics suite, and so it's on a Windows operating system.
Generally on Windows Server, if you're running the Historian, and in this case, it's a redundant platform on the edge. And then there's a number of ways to manage the gateway. In case, I'm not sure which system the gateway is using because you have the Hyper Collector there, probably a Windows system. But you know, if you had a simpler remote system, you might use an industrial gateway running Linux, maybe a Ubuntu or even Raspberry or some other Linux variant, and then you'd use Azure IoT Edge, and then the Iconics application IoTWorks installs Azure IoT Edge, leverages all that benefit of pushing the data back to a central server. Okay. Gotcha.
Thank you. This is kind of a split for Morgan and Mark, I think. Morgan, can you say more about the greater amount of trending data and historian data that this application provided to your customer? And then, Mark, how does the Iconics platform support redundancy and other protections for historical data and alarms?
Morgan
Sure.
first?
Sure. So as far as the trending goes, so on the on-prem solution, the redundant servers on the vessel, they're collecting that real-time data. So as fast as that data is collected, it's also stored in the historian. Everything stored in the historian is accessible through trending. So it's not set to a defined limit. So if it's there in the historian, it's available for trending. So this would go up to years of data. It just would depend on how much data the customer had. In this particular use case, drilling operations are usually short term. So they have a contract to go to a certain location and drill. And then as soon as drilling is done, they would go to the next location. So there might be breaks in time where the data is not present because they're not actively using the piece of equipment. But the data would still be stored there for historical viewing even when they move to the next location. Over to you, Mark.
Sure. So let's start with historical data redundancy, and so you can have combinations of pair. Normally you have a pair of servers, and so there's an active server and a backup server both running, and the backup server is constantly getting data files pushed. If there's a gap, active server goes down, the backup server, secondary server will take over. It's really server 1 and server 2, right? They can both be primary. And then there's tools that automatically fill those gaps in data. Very similar with the historical alarms. There's tools that fill the gaps in data. And then, of course, in the SOAP application and the Orion application, they had 2 sets of redundant servers, right, with the hyper collector in between. And just to expand a little bit more on that question about the data retention, the hyper historian has a binary format. It can go very large for we call hot data storage. That's directly in the local hyperhistorian database. It has archival capabilities. So you have archival-based hyperhistorian files that can be reattached and the data viewed readily. And then the ability to do what we might call as more cold data storage to other data elements like Azure Data Lake or Hadoop Data Lake, and then visualize and go retrieve those files and look at them. Of course, analyze using any variety of analytics tools that customer may want to use. But if you're moving from site to site, like in that case, you may want to retain the kind of current drilling location in hot data, and then have some historical reference for other purposes down the line. If you think about automotive or any kind of safety related equipment, you might want to retain that all the process data related to any piece or part that you've made for decades. And so that's something we can do with the hyperhistorian.
Okay. A related question came in, Morgan. They're asking, where are the data stored for your application, and can it be exported, and if so, what format? I'm not sure if they mean on the rig or in the cloud, but you can interpret the question any way you'd like.
Sure. So in both cases, whether it's on the vessel or in the cloud, all the data that's coming in is being stored in the historian. Through the trending tool itself, you can use that from the front end to do an export of the data. So you could select which data you want to view, then select the time range from the trend viewer, and then you can export that into multiple formats: Excel, CSV. I'm sure there's some others. Off the top of my head, I might have Mark clarify that for me. So you can access the historian itself and query against the historian to get data. That would probably be for a more advanced user. And there would be ways that you could set up reports that would access that historian data. But Mark, I might let you on.
There's an external SQL query interface that we call our hyperreader that allows for data to be queried, using parameters, passing parameters such as time and assets into the historical database, retrieve that data, and then to analyze it in an external data utility.
Gotcha. Thank you. Some questions about cybersecurity. The main question is, does this architecture comply with cybersecurity fundamentals? And what are some of the basic cybersecurity concerns that you guys might be hearing about from your customers, and how are you addressing them?
So the project-related elements, I think I'd have to defer to Morgan, and of course the Iconic software, if I can just give a little backdrop, is used in many critical applications, whether it be DoD or this kind of oil and gas kind of operation where you need to secure the data sources. We have OPC UA security, the security at the data integration level, at the edge to cloud, with the TPM management, with the encryption from the one data source to another, say, a data server, data client, and so all that data is encrypted HTTPS, and then of course everything's password protected, and so username and passwords can be synchronized with elements like Windows Active Directory or Azure Active Directory, or using the Iconic's own security server. And so every device, every data element, every screen, these are all individually or as a group definable for security and permissions, and also time of day and schedules. So a lot of security elements. The U.S. Pentagon, for instance, uses Iconic software for all of its mechatronics monitoring, hundreds of systems, and has for a couple of decades. Just by way of example, and in those cases, we've gone through many security analysis that also allow in the project to secure ports, and secure applications, secure desktops. So all of this is compatible. Now, in the project itself, of course, the tools are there, but the implementation comes in the project. And Morgan, maybe you can just elaborate a little bit more.
Sure. I think, a lot of what Mark just hit on is one of the reasons that we also use the Iconics platform, because of their security features. One thing that I think I could add on to what he said and customers ask for is access based on roles. So Iconic Security helps with that. So it's not just for login, but you can use the asset hierarchy that's been created to say, based on your user role, I will only want the person to be able to access data from this part of the hierarchy. And that data can be related to preventing screens, preventing read and write actions, whether or not they can change a set point or not. So there's a lot of features within security and how it relates to how an individual user can access it as well. And that's something that is very helpful to customers, especially if they have a system set up where they're monitoring different assets, maybe throughout a region or even worldwide. Then they can use users within a certain area and define them to only have access based on where they're located or what they're working on, and not have access to the entire system.
And those are really good points, and of course, that's prevention, right? So of doing something wrong. There's also detection, and within the Iconic system, every event is recorded, any set point change, any login, and all that data is available to our alarm system for alarms and alerts.
Excellent. this is for Mark or Morgan or both. Perhaps Morgan, can you explain how a system like Orion could be applied to monitoring other asset types or be used in other vertical industries?
Yes, absolutely. So really what we've done here is not unique to the industry. The only thing that's unique to the industry is how we've grouped the data and how we've visualized the screens. But the same architecture could be applied to any industry, whether that means on-prem you would have a full Iconix platform running the Iconix suite locally, or if you were just collecting data from a remote site and sending it up to the cloud. Really, it would just depend on how the customer wants to visualize their data and how they want to group their data. So I could take this same Orion concept and I could take it to, let's say, wastewater, and I could look at their system and think about how they are going to utilize their data and group the different water system components into data templates. And then data templates would go into the asset structure to make the hierarchy of how the data would be sorted. And then I could develop screens that go along with that so that the data would populate into those different screen templates. But the architecture could be exactly the same. I could have the servers locally that are used for a control room to manage the water system. And then they also could have a cloud element. Let's say that they have multiple control rooms that they want to have data in, and then they want to have an overview look, and that all that master data could be in the cloud, and then each individual location could have its physical servers.
Gotcha. Okay. Maybe Mark, this one is more for you. We've had a question specifically about pharma and or life sciences applications. Does Iconix have a reference case study for using Hyperhistorian in the pharma industry?
We do, and of course, Iconix has been around since 1986. So many of our pharmaceutical customers have used our TrendWorks over the years, and some of our largest have upgraded to Hyperhistorian. It's working very, very well for them. And of course, CFR 21 Part 11 is compliance is very important, and Genesis 64 has the pieces and parts for CFR 21.11, including all the event logging, as I mentioned, and tools for securing screens and logouts and permissions and etc. So yep, there are lots of them.
Since we're just about out of time, the last question is going to be about the cloud and Microsoft Azure. Knowing that it's a Microsoft operating system on the rig and you're using the Microsoft Azure cloud, could another cloud system be used, and how difficult is that to have a choice at the cloud level?
Morgan, I don't know if you want to take that.
I'll just say a little bit, but I'll let you answer that. But I think that one of the nice things about using Microsoft Azure is that Iconix and Microsoft have a pretty tight relationship. So some of the tools that Iconix have created work really well with some of the Azure tools that exist. I think that you could really use any cloud hosting environment. So Mark, I'll let you kind of add on to that.
Right. I mean, the simple answer is yes, and anywhere that you can host a Windows VM, we can run Iconix in the cloud. Each cloud has its own kind of unique set of characteristics that provide you with tools to help in a project. But yeah, simple answer yes. We certainly have many customers running Iconix in AWS, and I think you asked what the question is, what is cloud? Co-location and data centers and private data centers, things like a private cloud based on Azure Stack, for instance. All those are feasible. There are peculiarities, and I say that in a positive sense. For instance, with Azure IoT Hub, there's the native integration to their Azure IoT Edge. There's a number of security advantages to that, which are easy to implement. But of course, we support MQTT and REST services from Genesis to Genesis. We also have within Iconix, created almost a decade ago a reverse port 80 communication from frameworks to frameworks that is generally used over VPN, but can be used over the public internet. But you have to ask, what is your internet connection, your availability of VPN. Amazon has its own cloud services and edge platform and edge security, call it Greengrass. So all these are possible. And then of course, you have to look at the historian, hot and cold data, and where are you storing the cold data. It's not just about the SCADA system, but all the other systems that it relates to. And there are many tools in the Microsoft portfolio, as there are in others, that help with analysis, with hosting other systems. So the system-to-system communication is one of the things you have to look at. Of course, you can talk cloud to cloud. All those things are possible, and we have applications where Iconix is hosted in multiple clouds and talking relevant data, peer-to-peer. So, short answer, yes.
Well, in the interest of time, I'm going to end our question session and tell our listeners that anybody who submitted a question will be able to answer those questions via email after the presentation is over. But I want to thank Mark and Morgan for being here today and for both giving us an excellent presentation and providing us those detailed answers. I also want to remind our listeners that additional material can be found under the Handouts tab on your screen. And if you missed any portion of this webinar or would like to re-listen to it, it will be available on demand. And within the next 24 hours, you should receive an email with a link to that recording. You'll also receive a post-webinar survey, and we would appreciate it if you would take a moment to answer it so we can continue to improve your experience. On behalf of Automation.com, Iconix, and SOAP Engineering, thank you for your attention. This concludes our presentation.